Today we are going to talk about Lorentz force. You see, whenever you consider electrical charge, this is the electrical charge. Whenever the electrical charge is moving in the electrical field and whenever it is moving in the magnetic field, so there is a force acting on the charge. This is a charge Q. It is a point charge. So whenever the point charge is moving the electrical field and magnetic field, or both the field together, then there is a force acting on the point charge. So the force acting on that point charge can be studied with the help of Lorentz force. So Lorentz force is a combination of electric and magnetic force on a point charge due to electromagnetic fields. Now let us assume that the Q coulombs of the charge is kept in some electric field, and due to this electric field there is some force acting on the charge. Of course, whenever we keep any charge in the electric field, the charge Q move away from electric field. And let E of R be the electric field intensity at distance R. Then there is a force acting on the charge due to electric field. This force acting on the charge is given by product of quantity of the charge and electric field intensity. Therefore, force due to electric field Fe equals to product of amount of the charge multiplied by electric field intensity. Therefore, Fe equals to Q into E of R. So this force due to the electric field on the charge is given by Q multiplied by E of R. Now second case, we consider the charge Q is moving only in magnetic field. This is just a schematic diagram. To make you understand, I have drawn here the magnet. This is the North Pole and South Pole. And so these magnetic poles, North Pole and South Pole, they are spreading the magnetic field. And in this magnetic field, the charge Q is moving. So charge Q is moving in magnetic field now. Earlier we had considered only electric field. Now in this case, I am considering only magnetic field. So charge Q is moving in magnetic field. And when it is moving in the magnetic field, it has some velocity. So let us say V equals to velocity of charge Q. And B of R, the magnetic field intensity or magnetic induction, changes as the distance changes. So B of R is nothing but magnetic field intensity or magnetic field induction. Now when the charge is moving in the magnetic field, there is a force acting on the charge, and this force acting on the charge is given by Fb, that is a force acting on the charge due to magnetic field is given by V cross B of R multiplied by quantity of the charge. So the force acting on the charge when it is moving in the magnetic field is given by V cross BR multiplied by charge Q. That means the force acting on the charge when it is moving through the magnetic field depends upon quantity of the charge, velocity of the charge, and the magnetic induction. Now in third case, we assume that the charge Q is moving through both electric and magnetic field. So there is a force due to electric field, there is a force due to magnetic field. Therefore, the total force acting on the charge is nothing but addition of electric force plus magnetic force. As we already discussed, the electrical force is given by Q multiplied by E of R, and magnetic force is given by Q multiplied by V cross BR. Now total force is nothing but addition of electric and magnetic. Therefore, adding equation 1 and 2. So F equals to Q E of R plus Q multiplied by V cross B of R. Taking Q common, so we get here E of R plus V cross BR. This force, which is nothing but addition of both electric and magnetic force, this force is nothing but called Lorentz force. Now represent all these in form of vector diagram. So suppose this is the direction of magnetic field and V is the velocity of the particle, direction of velocity, angle between them is theta. Now direction of magnetic force is perpendicular to both magnetic field and the velocity, so it is given by V cross B, and it is P of R, V cross B of R multiplied by the magnitude of the charge, and this is the Q multiplied by E of R, that is nothing but force due to electric field, that is Fe, and this is equals to Fb. The resultant force is given by diagonal of parallelogram. So this is the resultant force, that is the addition of Fe plus Fb. So this is the vector diagram for the Lorentz force. Thus, the Lorentz force is combination of electric and magnetic force on a point charge due to electromagnetic fields. I hope you got an idea what exactly the Lorentz force is. Please write down your comments regarding the topic and write down your queries, what more you want to learn on this channel. Meet you with next topic. Till then, wish you good luck, all the best.